guys, today we are going to be starting chapter 11, which is all about hypothesis testing for means. We've already done hypothesis testing before for proportions, so I want you to use the sample data from class. So this was the sample data when I had looked at it on Sunday, but I will post the current data on Monday just in case some people added some new data points. I know in here it says take a random sample of 10, but because I'm not there today, we're going to do it this way. Okay, so we've got our sample here. I'd like you to use this data, pause the video, and go ahead and work through this, connecting to what you know about hypothesis testing for proportions. All right, make sure you've paused the video and you've tried it on your own first. And now I'll continue. So for question 1, I had my sample data, and maybe you copied from me, or if you took the sample data from the sheet that I posted, you could put all of this sample data into your calculator, into list 1, and then we're going to go to one variable stats in our calculator, and that's how I got these two values right here. For question 2, it says to state the appropriate hypotheses for a significance test. Be sure to define the parameter of interest. Okay, our hypothesis, remember that your null hypothesis is the claim that we are assuming is true. So because it says that it is recommended that teenagers get 8 hours of sleep, that is what we are going to assume is true. It does not mean that we think it's true. Okay, more often it is kind of what we're trying to prove wrong, but it's what we are going to assume is true in order to do our hypothesis test. Remember, when you are stating, we also are going to state our parameter. So the parameter here is mu because that's the population mean, and we are trying to find the true mean hours of sleep for Miss George's students, specifically AP Stat students. My null hypothesis is that mu equals 8, and my alternative is that mu is less than 8. We are looking at the problem. It says, does this provide convincing evidence that teenagers get less than 8 hours of sleep? And that's what helps us set up our alternative hypothesis. Moving on, we need to check our condition. So starting with the random condition, it's not the perfect random sample. You know, we're just doing our own class data because that's more fun and more relatable. Ideally, if you were going to do this, you would pull a truly randomized sample. So we're just going to say that because it says random in the problem, it's random, but it definitely could be better. The 10% condition. So, remember, random samples, the reason that we do that is so that we can generalize to the population. The 10% condition is so that we can sample without replacement. Once you answered my form once, you could not answer again. And so that is where we're going to say that 18 is less than 1/10 of all the AP students. And then lastly, normal. So we do not know that the population is normal. We do not have a sample size of 30 or more. So we have to just look at the sample data. So I've already have it plotted right here in a dot plot for my sample data. It doesn't have a heavy skew. Maybe you could argue that it's starting to look a little bit skewed, but it's not an obvious, very strong skew. So because the sample has no strong skew, we are good to go. All right, so moving on now, we want to find the formulas for mean and standard deviation of the sampling distribution. So this goes back to Unit 5. How do we find mu sub x bar? This is on your formula sheet. Mu sub x bar is just equal to mu. Well, for us, remember that mu is our null value because we don't know mu. That's what we're trying to find. And so instead, we're going to use the mu that we are assuming is true, which is the null value mu. So we're going to say this equals 8. Now, standard deviation sub x bar is also on your formula sheet. That is the standard deviation divided by the square root of n. Now, of course, for us, we don't have the population standard deviation. We only have our sample standard deviation. So that's okay. We're going to use s sub x divided by the square root of n. Technically, that would be called our standard error rather than the standard deviation. So that's what we're using for hypothesis testing. This right here, the first part, I'll make a note. This was from sampling distributions. But now, because we're in hypothesis testing, this is technically SE sub x bar. Now, for this specific problem, though, that is 1.646 divided by the square root of 18, I believe. Yes, 18. All right, I'm going to plug that into my calculator. And I get 0.388. All right, now we're going to draw a picture and find the test statistic. So I've got my picture drawn. I need to still label it. So the first thing that I'm going to label is, oops, I labeled this part wrong. It should be 8 in the middle because that's what we're assuming is true. And then I'm going to label my x bar. So our x bar was 5.3. Just double checking, which is less than 8. And then we're looking for 5.3 or less. I also need to label this, but we do not label the normal distribution for a t-score the same way we do for a z-score. And remember, we're using t's now because it's means and not z anymore like we did before. So for these problems, when we label our t distribution, we are going to do t of the degrees of freedom. So for us, this is going to be t of 17. That's how I would label this curve. And so now we're going to find the test statistic, which if you found it and you just used the z-score formula, you basically found the correct one. Okay, so this should still x bar minus mu over s sub x over square root of n. And I'm going to plug in our values. So 5.3 minus 8 divided by 0.388. And I get, whoa, negative 6.96. All right. So moving on. This is our t value. Now we're going to use table B. And maybe this is where you got a little bit stuck because we haven't used table B and it looks a little bit different than the z table. So we are going to, here's the steps, go to table B. So grab your table B if you have it, or go grab one from the front. We are going to find the correct row with our degrees of freedom, which remember is n minus 1. In that row, you're going to find the closest t values. And match the tail probability. All right, let's try this. So I've got negative 6.96. And I'm going to open up my table B. So I'm going to go to degrees of freedom is 17. And then I'm going to go across looking for, cancel. I'm going to go across looking for as close as I can get to negative 6.96. All right, for this one, it only goes up to 3.9, so that's going to have to be as close as we possibly can get. So going up, now that very last column, I see the tail probability of 0.0005, and that is going to be my tail probability, 0.0005. So I'm going to say here we got a p-value of 0.0005. Now you also have the option to use your calculator. Your calculator can do this for you. And because there is such a weird, like, find the closest value, and it's not very exact to use table B, I definitely recommend using your calculator when you want to find these. So in the calculator, we're going to go to TCDF, and you're going to plug in the lower, upper, and the degrees of freedom. So let's find that in our calculator. If you go to second VARS, so the distributions menu, TCDF is option number 6. Some of you might have a menu that pops up. Some of you with an older calculator, it's just going to say TCDF, and then you have to plug in to the parentheses. For us, the lower value, well, we know that we are below, and my t-score is negative, so I'm going to put a really big negative number, or I guess a really small, so negative 999,999, comma. My upper is going to be my t-score, so negative 6.96, comma, and then the degrees of freedom is 17. Close parentheses and hit enter. In my calculator, I got 1.15 e to the negative 7, negative 6. So moving 6 decimal places to the left, I get 0.000000115. So a very, very, very small p-value. Whether you use the calculator or you use the table, you should still get a p-value that leads to the same conclusion either way. And so what conclusion can we make here? So the conclusion works very similar to the way it did before, because 0.0005 is less than 0.05. We reject the null. And have convincing evidence that Miss George's class has a mean hours of sleep less than 8. All right, so we've done our conclusion, and we are going to now move on to the important ideas. But I want you to remember this conclusion very, very similar to the ones that we did before. All right, so this was just a very quick introduction to significance testing. We are about to move on to our next practice for significance testing. But before we do, I just want to summarize what we've done so far. So the first thing is I want to tell you again about the conditions that must be met. The first condition is a random sample. Remember, this is so that we can generalize. The second condition is the 10% rule. Remember, this is so that we can sample without replacement. The third condition is normal. And now normal for means we have 3 ways we can prove it. One is that the population is normal. 2 is if n is greater than or equal to 30, then by the central limit theorem we are normal. And 3, if the sample has no strong skew or outliers. All right, and then now we have our new test statistic. And we're using it to find the p-value. So we still have to draw our picture. This time this picture is a t distribution, which we are going to label t and the degrees of freedom. We still are going to put our mu in the center, or you can put 0 in the center if you make it the standardized curve. So remember, we've done that before where I would put on here my t-score rather than the x bar, but that's kind of up to you. My t-score formula then is x bar minus mu over s sub x bar divided by the square root of n. And then to find your p-value, we have two options. Either use table B, or you can use TCDF in your calculator, lower T, upper T, and then the degrees of freedom. All right, try this, check your understanding, and go on to video 2 to continue on with hypothesis testing.